Hello, and welcome to another set of demonstrations for Great Cow Basic. This time we're focusing on the PIC16F171xx chip family. Hello, my name is Venn. I'm one of the developers of Great Cow Basic compiler, along with many others, including Hugh Constantine, the original developer. And I'm going to take you through some new chips called the 16F171 chip family. What are they? They're a set of high performance PICs. They have digital analog peripherals, no different from anything that's come before. Um, they have 12-bit ADCs, standard communications in terms of SPI, I2C, and serial. They definitely have the pulse width modulation, but they have it in 8-bit mode and 16-bit mode for high resolution. We have CLCs, which is the onboard physical logic inside the chip, which we can use for specific functions, which we'll look into later. And this one has an op amp, which is pretty unique. It comes in various different sizes, from 8-pin to 20-pin, and I'm going to be using the 16F17126, a 14-pin device. What I'm going to take you through is 19 videos. We're going to start with an LED demonstration, hello world, but we're going to have to do some other stuff beforehand in terms of setting up the infrastructure. So let me just a few words on Great Cow Basic compiler. It is an open source compiler for microchip, PIC, AVR, and LGTs. LGTs, the Chinese clone logic green technologies. And now it supports the 16F171 chip family. I received a couple in the post last week, so I got to and made sure the compiler worked with them, and it does fantastically. So what is this particular chip I'm looking at? A couple of diagrams I have lifted from the data sheet. One is you need to connect to it. So you need to be able to put some volts on it, VDD and VSS. I'm going to be using 5 volts and 0. And I need to connect 3 lines to it for programming. That's a master clear through the VPP connection, and the data and clock on the ICSP lines. And we could spend hours on working out how to connect that with its decoupling capacitor, but you should look at the data sheet. Figure 4.1 tells you where to put the capacitor, how to do this wiring, but I'm going to make it much easier for us. I'm going to give you some information to make it a little bit easier. Why? Because I'm going to use one of these. It's a 2011 low pin count demo board. It's got 4 LEDs, a potentiometer on it, and a switch. And we're going to use those throughout the next series of videos. There is a PDF on the web that shows you the connectivities of how the 4 LEDs on port C are connected, how the pot is connected into an analog A.0, and how the switch is connected into the reset or A.3 port. So I'm not going to go into the depth of that because I'm also going to provide you a layout. And this layout is the same as this board. So it's got on there the 4 LEDs with its suitable resistors, a potentiometer, and the switch. It's also got a programming port, which I will highlight with my pen. If you can just hold on a second, I'll just change the ink color to red so you can see it clearly. There is a programming port here, which is the same on this board. Now, I'm going to just go back to here for a second. I'm just going to show you my lab, because in the lab here, I've got some stuff. I've got one of these boards. This one's got blue LEDs. I've got a PICKit2. I've got where's a PICKit4? I had a PICKit4 earlier on, but I've decided I'm going to use a PICKit2 for this. And I'm just going to connect it up. And the essential thing here is to connect it correctly. And we'll do that in a moment, but that's there. I've got a USB cable, a camera, so we can see what's happening. Let's install some software. you might not have the right software installed. So I want you to go and get GCStudio. It's the latest IDE from us. Go off to gbasic.com or get it direct from SourceForge. I'm just going to click on here. No, I can't because I need the pointer. And it will take me into the into my browser, and it will start the download process. Turn the lab off for you. There we go. And it will start the download. There we go. Look, 59, 1 minute. Well, that's quite fast, isn't it? But I'm not going to wait for that. I'm just going to cancel that and assume it's done because I've already got it in my download folder. Here it is in my download folder, and it's there. There we go. You can see it a bit better now. Double click that to install the software. You may get warnings for your operating system. Do the best you can to get around those. And I'm just going to say install it. It says, welcome to GCStudio. Take the defaults and walk through. My installation directory may be different from yours. I put it in GCStudio demo. Just put it in GCStudio, please. Do not put it, you put it in any folder actually, but GCStudio is the default. Install. It's now installing the IDE. It's installing the IDE compiler, demonstration file, support for nearly 1,300 chips, and a load of programming software. But what it doesn't do, we can't ship out licensed software, so it actually flicks up a little dialog to say, do you want to install some licensed software? This one happens to be PICKitPlus, and I'm just going to open that and clone it from an existing directory. I can do that because I'm the developer of that. This is where it's going to be cloned from, my existing directory. Select the folder, and it will put it alongside my installation. Trust me, we've installed the software. How do I know that? Because if I go back to my desktop, press Windows, GCStudio comes up, I hit enter, and it will take me into GCStudio. Here we have GCStudio. I've got it green and black. You could have it on any color you like, as far as I'm concerned. But essentially, this is it. Anything that's in green is comments. We have 5 lines of code here. I can zoom in that there for you by pressing Control and Plus. We can see the code now, not clearer. Here it is. Specify a chip. Do a loop. Do loop forever, and it pulses out on a particular port, and it will do that for 100 milliseconds, and then wait 900 milliseconds. And we're going to come into that later on and look at that in detail. What I want to draw your eye to is some icons at the top. These icons there are an F for flash. If you've made a hex, then you can just flash it. Assemble. Make a hexadecimal file is H, and mega hex and flash it is H with an F. So if I want to assemble make a hex, I just press the H key, and it will flash up some instructions, and it will have compiled it in less than 2 seconds. It compiled it for that particular chip. I can change this to an 18F450. Is that a valid chip? Or the RISC? There we go. It's compiled it now for an 18F. So it's quite fast. It's quite useful. But let's just look at getting the hardware operational first. So what I'm going to do, I'm going to go out to the lab here, and I'm just going to connect up my board. Inside of this board, I have a few of them here. Look, I have a yellow one and a blue one. These cost about £5-6 off of British pounds off of eBay, and I've inserted the chip I want in here. I'm going to push together the PIC kit onto this board. Very easily done. It's the same as on the breadboard diagram I showed you. You push it in, and then I can connect in a USB cable. Now, Just need to make sure it works. I'm going to start my software, and I'll do that with you from my start menu. Press the start menu, and here is my software. It's called PICKitPlus. I hit the button. It will zoom in for me. I'll just zoom in on that. When I find it, and I can then read it, verify it, erase it, etc. And let me just turn the lab camera on so you can see it. If I do an erase, you'll see it flash. Great. So we know it's communicating because it also says on the screen here 16F17126. Now, can I zoom in there for you a bit closer for the for that? I don't think I can. I think that's the, oh, there we go. That's a better view for me. Okay, great. So let me just close some stuff down. So what we've now got is the IDE running. We know that by using this piece of software here, we can connect, we can talk to it. So let's do some real work. Now, I selected a PICKit2. You don't have to select a PICKit2. You can use a Northern software programmer, PICKit4, whatever you're poisoned. It's just that PICKit2 is just like the easiest for me, okay? And if you want to contact me on how to make that work, don't, because I'm going to show you how to do it later on in terms of using other compilers, other programmers. So what I want to do now is just summarize what we've done. I downloaded some software, I installed it using the default values, I attached the microcontroller to the board, and I validated the communications with the programmer, the software. You have to do those things. That's just the basics. But now we can do some other stuff. What I want you to do, when you get this installed, I want you to press, I'm going to go into the editor, sorry. I want you to press F4 and view demos. And when you're in view demos, we're going to walk to the demonstrations for this particular file called the 16F17126 chip range demonstrations, and then we're going to take you through 3 programs. So, and with that, I'm going to do some work, okay? So I'm going back into my desktop. We've seen this before in terms of the editor. I can press F4 in here once I've clicked on it. View demos, select it and press enter. Then when I press enter, it opens up a new copy of the IDE, but now it's got a list of all the demonstrations, look, and there's a lot of them. So what I want you to do is I'm just going to pull this across. I want you to walk down to vendor boards, Great Cow Basic Demo Board, 16F17126 chip range demonstrations. Click it, and then you're in the folder. You'll see a GCB file. Click it, and it opens it up on the right hand side. Isn't that great? Look at that. To get rid of this walk-in window, press the Control B or the page at the top to shut the Explorer. Control B opens it, Control B shuts it. And here we have a program specific to this. And what I can do, I'll walk you through it, is essentially saying this is Great Cow Basic. Hash chip. You need this every time. You need to tell it what chip. Well, we know the chip, 17126. Good practice, option explicit. It means that we have to define our variables. We haven't got any variables, but it's still good practice. And I'm going to say the direction of port C.0 is out, and there is an LED attached to that on that board. And then I'm going to turn it on by setting it to 1. I can set it to 1. I can set it to 0, but 1 will turn it on. Let me just compile it up by pushing these buttons at the top and flash it. So I'm going to make hex and flash. You will see There's a lot of dialogue at the bottom about the compilation process, and it's gone into the programming event, and it's already programmed it. How do I know that? Because I can look at the lab and I can see there's an LED on. Go back into code demos, press the hex and flash again. I'll go straight over to the camera so that you can see it work. I can't even get there quick enough. It's flashing, and now the LED is on. So the key thing that we've done, we've defined the chip. We've defined the chip that's needed every time. We've told it to set the port as an output, and we've set it to 1. Hello world. Look at another demo, 20. Blink. Click on it. Click it twice, click it once. Click it twice, it opens it in the editor. Shut the Explorer. Same again. Chip, option explicit. Same. Now, this time we told it that the port is an out direction of the port. C.0 is an out. And we have a do loop. Do something forever, this means. Do it forever. Wait 1 second. Port.0 is 0. Set it off. Wait 1 second. And then turn it on. Repeat. Rinse and repeat. Rinse and repeat. I'm going to press hex and flash. Going to go to the camera. It's flashing. It's programmed it. 3 lights. Still working. It's finished. And the LED is now flashing. Cool. So we've got our first program inside. Let's go back to our code. Let's look at blink another way. It's 3.0.gcb. Shut that down. We've now got 3.0 loaded. Same, hash.chip, hash chip, chip name, option explicit. This time, we're going to use a constant to refer to the port. I'm going to say that LED1 is a constant that's referred to and points to port C.0. Then I say LED1, referring to that constant, is an out. Slightly different loop. Wait 100 milliseconds because I'm showing you that you can do it in seconds or milliseconds or microseconds, depends what your needs are. Then turn the LED on and off by using not. So LED1 equals not LED1, and it will do it. So let's program that. Have a look on the lab. It's flashing. So what we've got is a flashing LED, the blue LED. On the programmer, you can see there's power applied and that it's powering target into this board. The PICKit2 can draw a number of milliamps. We must make sure that we don't exceed them, but we won't in these demonstrations. Okay, we won't. But let's have a look back at our code because we can make another LED flash by changing just one item. I'm going to say make port C.2 flash because I've changed the constant. The constant is then used everywhere else in my program. It's a very good practice. Into the lab. I've changed the LED that's flashing. So it's pretty simple to use Great Car Basic. The essential lifeblood of Great Car Basic are these instructions. Define the chip, define constants or variables, we'll come on to that later in the week. Do some loops and turning things on and off at high speed. Things like setting up the chip speed, setting up the config is all done fully automatically. And we'll look into that, how that works later on. back to PowerPoint. Well, we've got 19 other videos to go through. But tomorrow, we're going to make 4 LEDs on that board flash with ease. We're going to walk you through the code. You can see how it works. You can connect it up yourself in terms of that board we showed you earlier on, or make your own breadboard. But that's what I wanted to show you. So this is a set of demonstrations for the 16F171 chip family. We'll call that a wrap.